Hello there, this is Holt, and we have a problem that reads find values of a and b so that f of x is continuous everywhere. And our function f of x is a piecewise function that has three parts, defining what our function looks like at certain intervals, for certain intervals of x. So the first thing I'm going to do is kind of think about what each of these functions kind of looks like. So the first one is actually equivalent to x plus 2 times x minus 2, just factoring the top area out, over x minus 2. Those cancel, and then when we get that, the first part just looks like x plus 2, which is linear. Now our next section right here is a polynomial, so it's actually a parabola, so it doesn't look like that kind of parabolic. And then our next section is actually going to be linear again. So what this is really saying is that if we had some graph, it would be linear. There's no extra variables in the first section, so it's just going to be the line of x plus 2. And then the next section, it depends on a and b, so some parabola. And then our next section is linear again. So let's say it looks like that. But we want it to be continuous, so we want to find where the a and b values are going to make it so that these all connect, so we get a continuous and that's not very good, but kind of the idea of continuity. So how are we going to do this? Well, we're going to look at our points of interest, which are 2 and 3, and assess the right and left limits at these points. So let's start with our first point of interest, which is 2. Let's look at the left limit. So we're going to say limit as x goes to 2 from the left, and which function as 2 approaches 2. We're looking at this function right here. So we're determining that this function is actually just equivalent to x plus 2, so we can just plug it in and see that it equals 4. Let's look at the right limit of that as well. Oh, plus sign indicates from the right and that's from the left. So if we go from the right, we're going to get this function. We can plug that in and we get a minus 2b plus 3. Now, because we want these to be continuous at this point, we're going to set them equal to each other. So then we get 4a minus 2b plus 3 equals 4. We want our variables on one side, so we get 4a minus 2b equals 1. And now we're going to look at our next point of interest, which is 3. So let's take a look at the limit as x goes to 3 from the left. Sorry, left limit now. It's actually going to be this one again. And plug that in, we get 9a 3, and let's look at the right limit now. This time it's going to be this one, going that way. And we're going to set the right limit equal to left limit, or the left limit equal to right limit, same thing, over here. So we get 9a minus 3b plus 3 equals 6 minus a plus b. Let's get our variables on both sides now. And we get 10a minus 4b equals 3. Now we're supposed to find a and b, and we realize that we have two unknowns, but now we also have 2 equations for the unknowns, so we can definitely solve for them. So let's do that now. So let me just copy them down real quick. All right, so the first thing I'm seeing is that there's a 2b here and a 4b here. So if we were to multiply this whole equation by 2, we would get 8a minus 4b equals 2. And then we could, since the a's and b's are all matching, we can do this here. We can say minus 8a. We can subtract this whole expression from this. b minus negative 4b, so it's going to be plus 4b. We'll cancel out 4b. It's 2, and then we get 2a equals 1, and a equals 1/2. Now we can plug that back into, I'll plug it back into that one right there, because I like that one. It's easy to work with. Our a is 1/2. That's 4 over 2 equals 2. Subtract 2 from both sides, we get negative 2b equals negative 1, 2b equals 1, and then divide both sides by 2, we get b equals 1/2. So we get a equals 1/2, b equals 1/2, and those are the values of a and b that will make sure that our function is continuous everywhere.